Okay, so we are on top page 21. This is the end of 3.4. Cool. So just a little heads up, like after our test Thursday, you don't have school Friday because faculty and service. You don't have school Monday because President's Day. Yeah, you have a 4-day weekend coming up. Yeah, cool. I have a 3-day. Yay. Okay, sophomores leave. Next week we'll do stats. Then we'll do a week of juniors gone, seniors do a little review for the final. You'll have some like daily worksheets to do. Wait, where's your hand for your senior? It's literally 2. Cool. Yeah. So I'll literally give you directions of who to check in with. Because you'll just come in here and cool. And then juniors get back. Right, we come back from the south. We'll do another week of stats. Have a small mini test. Cover vectors. Take the test. Shabbaton. There you go. That's the plan, right? So we're getting near the end for seniors. Make sure you don't forget Alex. It's a small but mighty thing that will help your grade or hurt it, depending on if you do it or not. Cool. Let's get going.
5 topics due every week?
There's 5 topics due every week until you finish the pie. 5 topics due a week until you finish the pie. Once you're done with the pie, guess what? It's cool. You're done, right? Bradley's literally done with her Alex in her high school career. That's amazing, right? Guess what? Tal and Andy are just chilling, waiting until I put them in the new class. They are literally done. Amazing. That's so good. It is one less thing for you to worry about. Cool. All right, so solve the following log equations. So the dealio is you want to get the log function by itself. Maybe I should do a 2-sec review. So the idea with solving these equations, if you have 2 exponential, and you can write 1 in terms of the other, right? Like for instance 4, oh, okay, 16 is just 4 squared. So you can write 1 in terms of the other to some exponent. Cool, you should do that. Otherwise, if you end up with an exponential equal to a number, you have to take a log of both sides. So this is roughly the same idea, right? So log equations, if you have e to the y equals 2, so I have an exponential on one side, a number on the other. We could take ln of both sides. And then property, the power property of logarithms, bring the exponent out front, so I have y times ln of e is equal to ln of 2, so we find, y is just ln 2.
No.
Literally, you take log of both sides. Question?
No,
You take log of whatever the base was. But more or less, we are going to be taking ln. When in doubt, you just take ln of both sides. Over here, I have log base 2 of x equals log base 2 of 6. Imagine if they have both log base 2, I could set the insides equal to each other because it's an equal sign. Or you could think about it this way if you don't like thinking of it that way. Imagine I put both of these as 2. I put both sides as 2 to the power of the side. Because I'm not raising each side by the power of e, I'm taking 2 to the power of each side. That's why this part will go away, and we're left with just the insides. More or less, if there's an equal sign and you have the same log base, you can just set the insides equal to each other. So the example 2a, the first thing you want to do, get the log by itself. Right now I'm multiplying 2 by ln of x. So divide both sides by 2, and you see ln of x is equal to 9. And then think about how you could get x by itself. What's wrong with what I'm about to do? So I'm literally telling you it's wrong. What's wrong with this? Right? X is just 9 over ln. Exactly. It's not a number. So I told you it was wrong. So hopefully you didn't write that down. It's not a number. This is what people are doing too often. I don't even know another way to show it to you. So I'm making it a point so you don't make that mistake. So it's not a number, right? It's always going to be attached to something. So it's just like when you have a square root. To get rid of the square root, you square both sides. To get rid of ln, you have to take e to the power of both sides. So I have e to the ln of x equals e to the 9. Hold the phone. E to the ln, that goes away, and I'm just left with x equals e to the 9. That's fine. let's simplify it. That's an exact answer. If you're super curious, that's just 8,103.08, but who cares? Because I go over the notes before class? No. Not gonna lie. But e to the 9 is fine. Alright, that's it. Alright, I want you guys to try out B. Try out part B. Try out part B. Think about it. First thing you have to do is get log by itself before you can raise each side to the power. This should be 10 to the x power. This should be 10 to the x power.
That's not log 10.
Right. It's not log 10 x, it's log 10 to the x. Because I'll show you what happens if I didn't do that. So I'm showing the way I'd originally written it versus having an exponent. So you get a different answer. So the left side is what I originally wanted you to do. But the right side, if it was 10 times x, it's a little confusing. Because in the second step, you would be tempted to say, oh, yes, yes, right? This is secretly base 10, so, this goes away not so fast. Not so fast. Because it's 10 times x over here. So you got to go through the product property of logarithms, and that's why I split it. Oh my gosh. So it's a little different, right? This is the way I'd wanted it to write. I wanted it to be the exponent instead. Okay. But it's an interesting exercise, which I want to show you what would happen. You only can cross it out if it's log base of the same base and then to an exponent. But you have to have it by itself. It can't be something multiplied. How do you feel about this so far? Yeah. Okay, let's do C. So I'm going to use the product property of logs. So I'm going to show you two different ways to do this problem. The first way is a little more easier if you don't have a calculator. Because you bring the 4 out front, divide each side by 4, and then you could just do the whole curly Q. So you see 5 to the 5th is equal to x, or 3,125 is equal to x. Whatever, it's fine. Now, there's a second option. What if you didn't do that first? What if instead you decided to curly Q it up immediately? That wouldn't be wrong. That would be fine. So you just have 5 to the 20th equals x to the 4th. And if you put the 4th root on both sides, you get the 4th root of 5 to the 20th, aka 5 to the 20th to the 1/4 power equals x. When you have an exponent to an exponent, you must do what? Multiply. 20 times 1/4 is 5. Once again, we get 5 to the 5th is equal to x. So it's the same thing. It's just showing you the pink way is the way I originally envisioned doing it, but both ways are valid. So now I want you to try D. Try out D. Move it over a little bit, give you time to start. Just can't. The printer's just, I can't connect. Yeah. Log base 5 of left is equal to log base 5 of right. Okay, since there's an equal sign, whatever's inside that I'm taking log base 5 of has to equal log base 5 on the right side.
But why did you have to write the 5?
You didn't have to. It's just I'm justifying. If I put 5 to the power of each side, oh yeah, 5 to the log base 5. Oh, that goes away and I'm left with x squared plus x.
Wait, so if there's a log of the same thing on each side, you just cross out?
Yeah, more or less you just set it equal to each other. I just set the insides equal to each other. X squared plus x is equal to 20. So x squared plus x is equal to negative 20. Just have to factor it out. What? Did I? Oops, sorry. Minus 20 equals 0. So there's a thing with logs. You can't take log of a negative number. I see I have, x could equal negative 5. What if I put negative 5 in for x? Huh? Well, let's see. So negative 5 squared is 25. 25 minus 5 is 20. Okay, that's fine. So, just always do a quick check to make sure you're not taking log of a negative number. Cool, let's try E. So we could, use the little trick that we just learned, right? If I have one log on the left, one log on the right, and they're the same base, just set the left and right side equal to each other. Issue is the right side has 2 logs. It'd be nice if I could combine them. What can I do? What's the rule, Tal? Yeah, log of something minus log of the same base of another thing. The right side is just going to be log base 2 of 10 over x minus 4. And since I have the same base, left and right, I can set the insides equal to each other. 5 is equal to 10 over x minus 4. Okay, so I see I have a variable. I'm taking log of a variable. I'm a little worried. But if I plug in my value I found, 6, in place of x, right up here, I have log of 6 minus 4. Okay, log of 2, that's fine. Because imagine if I put in, negative 3 here. What would happen if I put negative 3? I get a negative, and then, that's an extraneous solution. You can't take logs of a negative number. So it's not like I have to go through and show I'm checking it, but it's just make sure. Because if I'm taking log of a negative number, you gotta cross it out and it won't be an actual solution. So sometimes you can do a quick check. Other times it's literally as you're solving, you're like, oh, okay, then you hit the log later. I don't think that made sense. I'm not making sense right now. Are we ready for the next page? Okay, so this is definitely the hardest page of the chapter. So you just have to we're going to take something, I don't know, from yoga or sports or just life. We're going to take a big breath. Okay, and now exhale all the negativity, and we're going to have a positive mindset for the next page. Okay, because it's not hard per se, it's just a lot of steps and the order you have to go through. It's not hard, it's just so much to do. So all the negativity is gone. So before, what we try to do is we'd have the same base on the left and right side. That'd be great. We don't have that right here, right? I have a base 3 and I have a base 2. I'm trying to solve for x. It's on both sides and both exponents. So what you can do is take ln of both sides. Now, technically, you could do log, right? Common log, base sides, both sides, but I don't know, the common nomenclature, the way people approach this problem is take log of both sides. Okay, I took log of both sides, and then, I can use properties of logarithms to bring these down. So as soon as I'm done writing this line, I'm going to pause for a moment. Okay. So just took log of both sides, right? Natural log. Use the power property of logarithms to bring the exponents to the front. And now I must distribute. Okay, it's about this point where we start losing track of what our intention was. Like, what are we trying to do? Solve for x. Okay, trying to solve for x. That means I need x equals blah, blah, blah. So in order to do that, I should probably put everything with an x on one side, everything without an x on the other side, right? That's step one. I have to move everything with an x to the left, everything without an x to the right. Okay, I want to make sure everyone's ready for the next step. Okay, everything with an x in the term is on the left. Everything without an x is to the right. We're trying to get x by itself. Notice x is a common factor for everything on the left side, so I could pull it out. Right, I could factor out an x. I'm just trying to get x by itself. Yeah. And there's one more step. That's it. One more step to get x by itself. We have to divide by 6 ln 3 plus 4 ln 2. Okay, so if you're done with this problem and you understand it, you can go ahead and try B. All right, try out part B. Do you have questions about this one, yeah?
I still don't know why you chose L1 and not log.
You could do it with common log, but it's like the way the book does it, like the common way people would approach a problem like this with two different bases, just taking ln. Yeah. You can do it with common log, you'll get the same answers. Yeah.
Because I think on Alex
It does common log. So the example, this is an example in the book, and it shows natural log. As long as you're taking log, like of the same base of both sides, it'll be fine. Okay. Am I good to scroll over? No? Yeah? Okay. So I'll go over this problem for questions in a minute. I want to make sure I write this So you can check your answers. So there's 100% going to be a problem like this on your test, but I don't want you to be scared of it. I want you to like be ready. Yeah. Because it's a lot of work, right? Because first you got to take log of both sides. Okay. Then use the power property, bring it down. And then you have to distribute ln, right? The ln6 to both. Then you got to move everything with an x to one side, everything without an x. Then you got to factor out an x. Then you got to divide. Oh my gosh. This is a solid like 4-point problem. And normally your tests are about out of 40. So there's a lot of work associated with this one. It's a lot of work. So lots of partial credit.
Can you cross out both ln5?
No. It's kind of like if you had like x minus 4 over 2 plus x, like you can't just cross out the x's, right?
Yeah.
Because it's similar to that. Okay. Are we ready to move on? Do you need more time to write? Oh, wait a sec. Okay, so part C. This one's it's harder because you look at it and you're like, what the hell is going on here? But if I wrote a similar problem, I think you would be able to solve x squared minus x minus 2. Right? This would be a doable problem. So just be x minus 2 times x plus 1. But instead of x, here it's e to the x. So I have e to the x minus 2 times e to the x plus 1. Now, I gotta quit saying fun fact if it's not fun. Interesting fact, right? If you take e to the x times e to the x, this is just e to the x plus x, aka e to the 2x. That's why this is like x squared. I don't know. So I think someone in the other class asked me that. So now what we have to do, right? Take each factor, set equal to 0. So we're looking where e to the x is equal to 2. This is where we have to take ln of both sides to solve. Ln of e to the x is equal to ln of 2. So x times ln of e is equal to ln of 2. So I'm solving, like this step right here, I just wrote, you don't necessarily have to show that. I just want to show like where, like how did I get x by itself. So this other side, I set e to the x plus 1 equal to 0. Subtract 1. E to the x equals negative 1. Can e to the x ever be negative? No, no. And imagine you forgot that. If you would say, oh, x is just, ln of negative 1, right here, that's also a big old no because you can't take ln of a negative number. So this is what I mean when, like, it's not giving you answers, so you just, like, cross it out. That's showing. Cool. We're going to skip D because it's unnecessarily hard. I did it with my other class. This is not a question I would ask you on an exam. This is honestly probably this is like an honors level question. Yeah, that's fine. I gotta fight my battles. I want you guys to be able to do A and B without crying, so that would be great. It is what it is, realistic. So once again, we're trying to solve for x. Think, what would be an easy way? So I see I'm subtracting the two logs, which means I can combine the insides by writing them as division. So this is just 7x plus 3 over x plus 1 equals ln of 2x. The same log on both sides, so I can set the insides equal to each other. Multiply both sides by x plus 1. Move these over to the other side. And then we have to factor. So I'll wait a moment. Should you try factoring this yourself? So I wrote the case-if method on the left side here in pink, just to show you where it came from. So 2x plus 1, x minus 3. Cool. So I see one of my values, x is equal to negative 1/2, and the other is x equals 3. There is a very real possibility that one of these could not be a solution. Maybe both are a solution, maybe neither is. We have to check. It doesn't have to be like a full value check, but you know, we got to make sure we're okay. So I'm going to check x equals negative 1/2, and I'm just going to plug it into this guy. So ln of, let's see, negative 1/2. Negative 1/2. So 7 times negative 1/2 is negative 3.5, plus 3 is negative 1/2, over 1/2. Oh, so this is literally negative 1. This is taking ln of negative 1, which I can't do. And the right side, I have ln of, let's see, negative 1/2 times 2 is negative 1. So although this is technically true, right? Ln of negative 1 is equal to ln negative 1. You can't take ln of a negative number. This is not a solution. Goodbye. Okay, cross that out. Let's see if 3 is going to work. You know, I'm only plugging in positive numbers. We know it's going to work. You don't have to like go super hardcore checking it. You just have to make sure you ensure you're not taking log of a negative number. So 25, so I have ln of 25 over 4, 24 over 4, which is ln of 6. Then ln of 2 times 3, which is ln of 6. Okay, that's fine. This is an answer. We're going to do F, but instead of 12, you make that side a 2. Yeah. Do we have questions over E before I move on to F? You guys want to try F yourself first? Happy Monday to you too. Okay. So, wow. Okay. Good problem to have. All right. So I have the same log base, and I'm adding them. That means I can combine them by multiplying. Wonderful. 12x times x minus 1. Oops. And this is going to equal 2. Okay. So I have log base 12 of 12x squared minus 12x is equal to 2. So I can just do the little swirly swirl. I see 12 squared is equal to 12x squared minus 12x. That's a lot of 12s. We could do one of two things. We could divide everything by 12, that's fine. Or move the 12 squared to the other side, factor out of 12 so it's in front because we know it's not going to impact our solutions. I just like making it a little simpler. So I'm going to have 0 equals x squared minus x minus 12. Because you know 12 squared is 144. If I subtract it, move it to the right side, that's why it's a negative 12. Fully factor this out. I have x minus 4 and x plus 3. So I see x is going to equal 4 and negative 3. Exactly, so we have to check. So we're not done. That's why I have not boxed anything yet. So we gotta check. We can.
Anything you did with the 12, you went from 0 equals x squared minus x times 12. What happened to all the 12?
I divide everything by 12. Yeah. So check -3. So I have log base 12 of -36 plus log base 12 of -4. And this should equal 2. Well, I mean, technically, if you combine them, right, you're multiplying two negative numbers, but can't take log of a negative number. This is not okay, because this is not defined, this is not defined. So, nope. You can check 4. So I have log base 12 of 48 plus log base 12 of 3. No, wait. 4 minus 1, yeah, 3, okay. Equals 2. Let's see if that's true. I'm going to use rule of multiplication. 48 times 3 is 144. And 12 to what power is 144? 2, so we know it works, so it's an answer. Cool. Okay, so you have the last 15 minutes to work on homework. Alex, Coolio, gonna hit the review hard tomorrow.